How do we learn about the universe? In the first module on observing, we're going to learn about the large telescopes under construction at my university and elsewhere that are transforming our view of the universe. We'll learn about adaptive optics, a method for returning the sharpest images possible from the ground, images that rival or even eclipse those from space-based observatories like the Hubble Space Telescope. We'll also learn about the detectors that astronomers use, which are just fancy versions of the CCDs in your cell phone or your camera. But they're research grade and able to take billions of pixels of imaging in one shot. We'll also learn about space astronomy and what particular types of instruments and telescopes are launched into Earth orbit. Space telescopes cost 10 or 20 times as much per square meter as a ground-based telescope, so you have to have good reasons to move into space to do astronomy. We'll also learn about clever ways of combining separate telescopes to give the illusion of having a mirror that's the full span of the distance between the telescopes. This is called interferometry. It's been used in radio astronomy for over half a century and is now emerging as an optical technique. Then we'll look at the premier telescope of space astronomy, the Hubble Space Telescope, well into its third decade, still taking magnificent images and data that all astronomers want to get their hands on. We'll look at Hubble images and learn a little bit about the history of that important project. Then we'll move back down to the ground and look at the large telescopes under construction. After 50 years of no telescopes much larger than 5 meters, we're in a glorious time where a dozen or more 8 to 10 meter telescopes have been constructed, and astronomers have their eyes on behemoths 20 or 30 meters across. We'll look at infrared waves and invisible waves that go beyond the visible spectrum to open up the entire electromagnetic range for the universe to observe, a factor of 1 trillion in wavelength. And we'll even go beyond vision to talk about what is the frontier of detecting the universe, the search for gravity waves. Finally, we'll look at where this all takes us in terms of looking back in the universe towards the Big Bang, the potential to see the very first fractions of a second of the infant universe. Space astronomy and ground-based astronomy are in a time of enormous change driven by technology, and these are exciting times for astronomers.